everybody, it's Miss Hill back again with Exponents Part 2. So today we are going to add on to what we learned last week. Last week we talked about multiplying like bases. We talked about dividing like bases. And we also talked about that zero property. Today we're going to add on two more properties that have to do with exponents. The first one is called the power to the power property. I got the power. Sorry. And the next one is the negative exponent property. So we're going to tackle both of those, but before we do, I always feel like it's really important to take a minute and review what knowledge we imparted last week and then build from there. So let's take a really fast recap of what it looked like last week. So I'm just going to call this section review. And I'm going to take a fast tour. So the first thing that we talked about last week was multiplying like bases. You're probably thinking, why do I have to write this down when I already wrote it down last week? I promise this works. If you take that knowledge and actually take the time to put it down on paper, that process will help you understand it. So here we go. I was multiplying like bases, right? And what we learned was in order to do that, all I needed to do was add up those exponents. An example of what that might be is, let's say that I had 5 to the 7th and I was multiplying by 5 to the 6th. I needed to keep my base and I just needed to add up those exponents, right? So that's going to give me 5 to the 13th power. The second rule that we talked about last week was the opposite of that, which is dividing like bases. And we learned that in order to do that, we needed to subtract our exponents. So let me use the exact same example. If I've got 5 to the 7th and I'm dividing this time by 5 to the 6th, I am going to, again, keep the base. This time I am going to subtract my exponents. So I get 5 to the 1st power. I don't ever say that as 5 to the 1. I'm going to say 5 to the 1st power. All that means is I've got 1 5. No multiplying happening. So I just got 5. And then the last rule we talked through was the zero property. And what we learned is that any power, and remember a power was the base and the exponent, so any power with a zero exponent just equals 1. The whole entire thing is going to be equal to 1. So let's say I had this 5 to the 7th, but this time I was dividing it by 5 to the 7th, right? I would still take those exponents and I would subtract them, which 7 minus 7 is going to give me 0. So what happens is that entire answer converts to 1. And we walked through using the expanded form to show where that's coming from. So if you still have any questions about that really weird property, take a look back at your notes from last week where we expanded that guy out. Okay, so that's a little quick review. Let's jump into this week's power to power property. So I'm actually going to title this next section Power to Power. And what I'm talking about is a slight difference between multiplying like bases. So if you look at our example there at the very top of the screen, it said 5 to the 7th times 5 to the 6th. With power to power, what that would actually look like, the difference here, is I could still have 5 to the 7th power. That would be totally fine. But it would have parentheses around it, and I'd be raising it up to the 6th power. So notice I really only have one base of 5. Inside the parentheses, it's saying I've got 7 of those 5s that I'm multiplying. But then what does that 6 mean? That 6 means I have 6 sets of 7 5s. So really what I have is if you could envision this in your mind, writing out 7 5s that you're multiplying and then doing that process 6 times. So you can hear in my language, I was multiplying 7, right? And I'm multiplying that 6 times. So really what happens here in a power to power is I'm going to keep my base, and instead of adding those exponents like I did up here with multiplying, what I'm going to do is I'm going to multiply those exponents. And so that gives me 5 to the 42nd power. Let me give you an example with some smaller exponents so we actually could write it out in expanded form. So let's take it back. Let's say our base is 2, and that's raised to the 3rd power. And then let's say that whole power is going up to the 2nd exponent. The way I would think about that in my mind is I've got 3 of those 2's that I'm multiplying together. So let's write that. 1, 2, 3. I've got 3 of them inside those parentheses. And that 2 that's outside says I have 2 sets of those. So there's one set. And then it's like I have a whole nother set, a second set of 3 2's that I'm multiplying, right? Set 1, set 2. So basically, if I look at what that would be, my base stays a 2, but now I have 1, 2, 3, 4, 5, 6 of them, right? So if I take this answer and I look back at where I started at the beginning, the relationship between 3 and 2 and 6 is that I am multiplying the exponents. So different. I'm not adding them. That would give me 2 to the 5th, right? I'm multiplying those exponents when I'm in a power to power situation. Let's write out that rule because my goodness, we like a rule. So my rule here is when raising an exponent to another exponent, all I need to do is multiply the exponents. I want to keep the base. Nothing happened with that 2. I just want to multiply my exponents instead of adding them. Okay, let's take our next move into negative exponent property. So this one, I am going to walk through some examples first and show you what it might look like to get a negative exponent. So we'll title this negative exponent property. And I'm just going to use division as an example. So let's say I have the problem 10 to the 5th divided by 10 to the 8th power. So let me write that out using the actual fraction bar instead of the division symbol. What that relates to is 10 to the 5th over 10 to the 8th. If I were to just write that out using the rule, if I'm dividing like bases, I subtract my exponents. So I'd keep my base. I'd subtract 5 minus 8. Again, keep the base. If I'm standing on 5 on a number line and I'm subtracting 8, meaning I'm moving left 8 spots, Where am I going to land? I'm going to land at -3. Now, I don't know about you, but I don't know how to multiply something a -3 number of times, right? So again, just like a number line means direction, a number line like with a negative is going to mean going to the left, and a positive means going to the right. So a number line has direction to it, and a positive and negative is giving you that direction. The same is true when I'm talking about exponents. That positive and negative is giving you direction about whether or not it's really in the numerator or the denominator. Let me show you what I mean. If I were to take this and write it out in expanded form, that means I have 5 of these 10s in my numerator. In my denominator, I have 8 of them. 1, 2, 3, 4, 5, 6, 7, 8 of them. And I'm going to cancel out by identifying that this 10 and this 10 divided by 10 would equal 1. 10 divided by 10 would equal 1. These are canceling out. This set cancels. This set would cancel. This set would cancel. Now what am I left with? It looks like I'm left with nothing in the numerator. I'm actually left with 1, right? Because when I did all of that division, anything divided by itself is 1. So I've got a 1 up there. In the denominator, I have 1, 2, 3 of these 10s. So I have 10 to the 3rd power. This answer and this answer mean exactly the same thing. So my negative exponent property simply means that when I get an answer and my exponent is negative, in order to write it in the best possible way, I am going to find the reciprocal, meaning if it's in the numerator, I'm dropping it into the denominator. If it's in the denominator, I'm popping it up into the numerator, right? Reciprocal just means opposite position. Just like on that number line, that +3 and that -3, they were in opposite directions, still 3 spaces away from the 0. So if I want, I'm actually going to write that out so that I can say that 10 to the -3, which my brain doesn't know what that means. I don't know how to multiply something a -3 times. But I do know what it means if I write it as a fraction and put that 10 to the -3 in the denominator, right? Because what's really hanging out here is a 1 under there. So all I have done in order to get here is I have flipped the order and found the reciprocal. So let's write out that rule. To convert, that means to change, from a negative exponent to a positive exponent, all I need to do is find the reciprocal. Not a fun word to spell. Reciprocal. Reciprocal is just meaning opposite position. So if it's in the numerator, drop it in the denominator, and vice versa. So I'm actually going to write that down here because I'll forget that after the video. Reciprocal means opposite position, basically. Let's do just 2 examples so that this can cement in that gorgeous brain of yours. Let's say you do a problem and you get the answer of 10 to the -6th power. The best way to write any answers with a positive exponent. So all I'm going to do is I'm going to convert that into the reciprocal. Right now that's in my numerator, so I'm going to write it as the opposite and put it in the denominator, and by doing that, it makes my exponent positive. The opposite is also true. So if you start with 10 to the 6th power and you flip it into the reciprocal, you also have to flip the sign. Now, I don't know why you do that, but you could absolutely, that would be written in the same way, but with a negative exponent. I hope that these notes were helpful to break down some information. Your teacher is going to share the PDFs of these notes with you and then play a Kahoot today. So have some fun with exponents. See you guys next week.